This is Magicv. This is a GUI that we developed to help make the process of using electrochemical simulators easier. So I'm going to walk through how to use this GUI on an example ECE mechanism. So we're going to start by drawing out the chemical species that are going to be involved in this ECE mechanism. So we have our starting material and we have our product. I'm also going to assume that the chemical step involves a reaction with some other starting material. I then need to place the intermediates between them. So after the first electrochemical step and after the chemical step, we have our intermediates. If I wanted to, I can go through and rename these. So in order to do that, I would just double click here and I could rename it starting material. Start here, double click again, end. To place these shapes, what I did is I selected the box over here with a left click and then I selected on the canvas. I'm not dragging, just selecting. Now I want to define the transformations between them. Because this is an ECE mechanism, I'm going to select electrochemical step with a left click, then select start and I1. I'm going to do that again between I2 and the end. And then I'm going to draw the chemical step by selecting the chemical step over here on the left and then clicking I1 to start drawing an arrow and I2 to end it. I'm going to add this starting material to this conversion. So it goes into the arrow. That means it's part of the reactants for that chemical step. Now what I can do is I can go through and modify these properties. To modify your properties, you want to go ahead and either right click or click this green button over in the top, and that'll put you in toggle mode. This allows you to no longer place shapes whenever you click on the main canvas. Instead, you can interact with that canvas. So we can modify the properties here. I'm going to assume that all of these are going to be reductions. So as a result, I want to start my, I'm going to offset these standard potentials so you can see something's happened. So I'm going to put 0.3 there and negative 0.3 here. What I'm doing to modify these properties is I'm just selecting the shape, then I'm going over, or selecting the arrow, then coming over here to the step properties and changing stuff around. If I wanted to, I could copy this board state, and then if I move it around, whenever I paste it back, it gets replaced by what was originally there. Then what I can do is I could, let's say I added a new reaction. I don't like this reaction, so I'm going to delete it. So to do that, I select the shape, press the delete key. If I didn't like the fact that I just deleted that, I can undo that series of actions and redo them again. Now we can check the graph. This shows you what's going on in the back end, what the computer is thinking you have reaction-wise. This aligns with what we see here. And to confirm that, what I'm doing is I'm just going through and I'm saying, okay, we have our starting material that undergoes an electrochemical step to generate I1 and so on and so forth. That's how I verify these things. I can then select the simulation model. So for the console, you can only download the results. You can't actually see them. I can see the results, so I'm going to keep console selected because it's probably the most flexible to these very strange reactions that we can draw. We can then select the module that COMSOL is using. We can then modify the CV parameters, so our starting potential, which I'll change slightly just to show you how, as well as any other parameter that you might see on a potentiostat. We can then change what parameter we vary. So if I selected, for example, this start to I1, this has selected this electrochemical step. So any continuous property there is now modifiable. So I can further define a property that needs to be varied. I'm not going to actually do that though. I'm going to stick with scan rate and vary from 0.01 to 100. I can then change the number of scan rates. So their scan rates are taken on a logarithmic scale between these values. I'm not going to do that, nor I'm going to select a second parameter to vary. I can then change how I normalize the results. So in this instance, if I normalize by the square root of this scan rate, my currents are going to look better. They're going to be closer together. They're not going to disappear into nothingness whenever we get to a slower scan rate. So what I'm going to do now is I'm just going to run this simulation. If we wanted to, we could also upload experimental data, which would be plot on the results that we see. If I didn't like the fact that I just submitted this job, I could press Halt CV Simulation, and that would cancel the current action that I'm doing. Okay, now the CV simulation has completed successfully, so we can view its results. And we can see how scan rate has affected your current over as that scan rate parameter is varied. If I wanted to download the console model that created this, I could do so by clicking here. That downloads the MPH file. I could also download the data that's been generated. I could also report a bug. So if you see anything weird that goes on here, you can type in here and you can send a report. If you see multiple things happening, I recommend submitting one bug report because you are limited on the number of bug reports you can submit. And this just acts as a backend measure to preserve the backend. Well, and that's all I have for you. Thank you very much. I hope you find this GUI useful.